All right, this is the 9 p.m. Zoom meeting for Math 1111 on October 15th, and we have some participants tonight. I can't see your names because I've got it set to the camera. So y'all came out tonight. Did y'all have questions or problems y'all wanted to see?
I really just wanted you to just solve some. I mean, I don't really have any questions.
Okay. Anybody else have any specific problems or questions? Well, I don't know if you got a chance to see my thrilling 12 p.m. video. Should I start from the beginning and explain what long division is all about? Or can we just charge into the problems?
You can just go ahead and charge, I guess.
Okay.
Yep, go right on in.
All right, you're familiar. Now, the book makes a big deal about the four magic words: dividend, divisor, quotient, and remainder. Now, are y'all familiar with those four words and would be able to pick them out?
Yes, sir.
Okay. Well, let me put up the book and you see if you can point to a problem. We'll start with 3.3. So 3.3 starts right here, and it reads like gibberish, but once you see a couple, it isn't really that bad. Synthetic division is a special case where you're dividing by a first power. And you're allowed to drop all the letters and work with numbers. I never learned it, and because it's such a special case, I don't see any need to learn it because long division does everything. To me, it's easier if you just learn one procedure, which is long division. Now, it reads probably like gibberish, but basically they're saying divide this P of X, whether they give you a bunch of PXs here in each problem, by this D of N. They're calling the D of X the divisor. Your quotient appears at the top of your bracket. That's otherwise known as the answer. Most of the time, it's the total answer. If it's even, if there's a remainder, then you've got to add on remainder divided by divisor. So is there any one of these particularly you would like to see?
Whichever one you would recommend us to see.
You know, you can do it, by 7 and 8, they're getting a little longer. I think I did 3 in the video. Do you want the instant replay?
I saw 3. Can we do 7?
Sure. This is off page 309, section 3.3, number 7. Can we, instead of copying down exactly what's here, can I shorten it up and just jump right into what you need to do?
Yeah, that'll be fine.
Okay. So what you need to do is you need to take the divisor and divide it into what they're calling the polynomial, 2x to the 4th minus x cubed, 9x squared, and I'm going to tack on a 0x and a 0. I always feel whatever the lead power they give me is, it works back to a number. If there's any missing powers, I always fill them in with zeros. So can you see that they're giving me the P of X in number 7? They're giving me the divisor, x squared plus 4. Divisor goes outside. The P of X goes inside as the dividend. All of these are going to work that way. Are we ready to charge in?
Yes.
The game, it's just a game with multiple rounds. And the idea is you're creating your quotient up here, which is also sometimes can be the whole answer, and sometimes, of course, it's just a part of the answer, or your answer starts with it. But you're trying to create this quotient up here. You start the game by asking, this piece times what would give me this piece? In other words, x squared times what would equal 2x to the fourth? Can you tell that'd be a 2x squared? And that's what goes up here. Your deafening silence. Is this complete gibberish, or does this make sense?
No, I understood what you said. I was just
Okay.
waiting.
Same here.
Okay. So then what you do is you multiply back. Now, the only difference between this and numbers is that numbers, you just do numbers and write your answer down. With these formulas, you've got distributive properties. So when you multiply this back, you're multiplying all the pieces like it's a distributive property. So 2x squared times your x squared, that's your 2x to the fourth. And 2x squared times your 4, that's 8x squared. What you want to do is be very careful to line up your like pieces, your like powers. Then what you do is you subtract, but again, you got multiple pieces, so that's a distributive property. So to remind everybody, I try to write that in parentheses. This is how every round is going to work. And as you do more rounds, you create more pieces up here. Now, at every round, these lead pieces always match and they always cancel, always. If they don't, you're screwing up. Questions about that?
Nope.
Okay.
No, sir.
No, okay, so then you want to go, you want to bring down your minus x cubed. There's technically a 0x cubed here. So minus 1 minus 0, just will still be a negative 1x cubed, but you want to go 9 there minus 8. That would leave a positive x squared. Still bring down a 0x and a 0. Are we ready for round 2?
Yes.
Same game. X squared times what would be equal to negative x cubed? Can you tell you'd need a negative x? That's your next piece up here. And when I multiply back negative x times x squared, I get negative x cubed and a negative 4x. See, I don't line that up under the x squared. Negative 4x lines up over here. Subtract, put this in parentheses, line, and subtract the like pieces. Again, a negative minus a negative, that's, negative add positive, these cancel. And 0 minus negative 4 is a positive 4x. I'll bring down the plus 0. Round 2 is done. Questions about that?
What happened to the x squared?
I'm sorry. Yes. You're absolutely right. I screwed it up. There should be an x squared there. And the plus.
I was a little bit worried about that.
Yeah, no, you're absolutely right. Yeah, I missed that. You're absolutely right. Are we ready for round 3?
Yes.
Well, it's almost so easy it's hard. X squared times what is an x squared? Have to be a 1. So 1 times x squared is x squared, and 1 times 4 is 4. I line that up under the 0. Subtract, parentheses. X squareds cancel, x squared minus x squared. 4x comes down. And then 0 minus 4 would be a negative 4. Game over. Why? Do you understand why or how we know the game is over?
Yes.
It's because this power is less than this power. Notice I can still play when the powers are equal. X squared there, I can still play. But when that comes down with an x, you'd have to do a 1 over x or something to get this to match and cancel. And so you don't, your game's over. This is the remainder. This is the quotient. This is the divisor. That's the dividend. Now the trick is, if you want to match the answer in the back of the book, is to read how they want you to write your answers. And they wanted you to write your answers as quotient add remainder divided by divisor. So the answer, I'll write it out in function form, plus remainder divided by divisor. That would be the 2x squared minus x add 1. Add the remainder, which is 4x minus 4, and divided by the divisor of x squared plus 4. Questions about that? Now, if you're wondering what is all this gibberish and everything about, that answer's in 3-4, but I could just show you as a check, but I don't know if you want to see it. It just adds to more gibberish. You really started, we're showing it as long division, but you're really taking 2x to the 4th minus x cubed plus 9x squared and dividing it by x squared add 4. All right, that works out by this whole procedure, and we're saying the answer is this. Well, this is a common denominator form. This is a busted up form. But if you want to check if this is right, we can make this a common denominator by putting this under this and then putting that up there, FOIL it all out, bring this in, combine all the pieces, and you'll come right back to this. Now, I would be thrilled to show you that. Or do you believe? We're so awestruck, we've struck dumb here. We can't. Do you all want to see this put back together? It's like taking Humpty Dumpty and busting it apart, but you can always put Humpty Dumpty back together again. I have got to quit reading nursery rhymes to my kids.
What I mean, I guess, yeah. Will it be on the quizzes and the tests?
Not really, but I'd like to do one just to show you it's not all hocus pocus.
That'll be fine then.
You want to see it done?
Yeah.
Okay. So what we're saying is, if I get a common denominator, and I froze. Okay, I'm back, maybe. Okay, get a common denominator. All right, that means I have 2x squared minus x add 1 over my x squared add 4, plus my 4x minus 4 over my x squared add 4. See, I've put this under this for a common denominator, but if I do it to this bottom, I have to do it to the top. Almost like as if I did a cross or a thing or a cross up there. So now when I combine these fractions, I get a single x squared plus 4. That's my common denominator. I'll try to leave it in the picture here. So I get a 2x squared minus x add 1 times my x squared add 4, add 4x minus 4, and I'll get all over x squared plus 4. All right. All of this must equal the 2x to the 4th minus x cubed add 9x squared. So the rest of this is to FOIL this, combine all the like terms, and if it doesn't boil down back to this, I will quit on the spot. I like a little drama. All right, so you see you get a 2x to the fourth, a 4x squared, sorry, that's an 8x squared, do it right. My job is at stake. 8x squared minus x cubed minus 4x plus x squared plus 4. Is that too fast? It'll catch up. An unstable internet here.
You
I teach
froze
it.
on me.
What now?
You froze on me.
Okay, I can go back through it if I'm back
No,
now.
like, I didn't hear what you said at
Oh,
all.
I teach it as rounds of distributive property. So I distribute this through this, write it down, sort of round one. And then I do the minus x through this, that's minus x cubed and minus 4x, that's round two. And then finally easy distribute one through, doesn't change, plus x squared plus 4. Still have this plus 4x plus, minus 4. It's all still over x squared plus 4. All right, let's combine all the like terms. 2x fourth minus x cubed. We've got 8x squared plus x squared is 9x squared. I lost off, so that's a 4x. Whew, okay, there was a 4x there. So minus 4x plus 4x plus 4 minus 4. And I'm back to this over x squared plus 4, which is what I had up here. I don't know if that proved anything to anybody or only to me. You might from now on check the answers in the back of the book.
I understood it.
Okay. Do you want to go on to the next page? You're basically doing the whole point of this section is just to teach the procedure of long division. And then they show you what they're using it for in 3-4. So you've got this kind of long column. I think I asked down through 37. I think I went 9 down to 37 here. Notice that they say you can use synthetic division here, but you don't have to. If you know, I run into people who've learned synthetic division and swear by it. And if you're one of those people, help yourself. You'll get the same answer. But I don't teach it. I do it all by long division.
Is synthetic harder?
No, actually, it's supposed to be easier. Because notice how in all these synthetic problems, see how you got first power on the bottom? It's a specific procedure that only works with first power on the bottom. And it lets you drop all the coefficient. Actually, it lets you drop all the x's. Only keep the coefficients. I don't see any reason to learn a separate procedure that only works with first powers on bottom. I personally would rather stick with a procedure that works every time. The last two I asked for were 63 and 65, and those are kind of backwards problems. You start with the zeros, and then they want you to find your polynomial.
Could I see one of those?
Sure, which one you want to see?
Whichever one, it don't matter.
Okay, you want to see 63?
Yeah, that'll be fine.
Okay, so what they're telling you, and it's really, to me, this is in the wrong section because they really don't cover this until 3-4. But we'll explain it here. This is problem 63. Find a polynomial of degree 3. That means its lead piece will have an x to the third. The coefficient doesn't matter what the coefficient is. Degree refers to this power. Zeros. -1, 1, and 3. So that's what this says. Okay, here's what they really haven't explained unless you've seen 3-4. When we say a 0, that x equals -1 is a 0. Okay, that means I'm just gonna use the p of x from last problem. I'm just gonna use a random p of x. It doesn't work, but I'm trying to illustrate this. Let's say I have the p of that. What was the last problem? It's number 7, wasn't it? No. It was number, yeah, it was 7. 2x² minus x cubed and 9x squared. Minus x cubed, 9x squared of this. All right, it probably isn't because I'm just randomly making this up. But you understand that means I can plug in -1 to this and I get out 0. You get that, right? This means that you'd have a factor of x plus 1 times other stuff. See, plug in -1, get 0. I'm just making this up for purposes. So you have to have a x equal -1 over here factor. It has to switch signs, so I can plug in -1 here, +1, and get 0. This is the basis of this. This is the entire basis of 3-4. Does this make sense?
Kinda.
Okay, so when they tell me that I have a 0 of x equal -1, that means I get a factor of x plus 1. When I have a 0 of x equal 1, I have a factor of x minus 1. See, I froze. Okay, we're back. So I can plug 1 minus 1 and get 0. Up here, I plug -1 plus 1 and get 0. And the other 0 is 3. So you see its factor is x minus 3.
Yes, I understood that.
Okay, so to create your polynomial, you multiply all the factors. So your p of x, x plus 1, x minus 1, x minus 3. And so you can stick in these individual numbers and you will get 0. And now I'm going to FOIL it all out and create the answer in the book with it expanded out. You see how it has an x to the third because you get x times x times x, that's an x to the third. Questions this far?
No, sir.
All
No,
right,
sir.
how you FOIL it out is up to you. You can only FOIL 2 at a time. So you could do the first 2 and hold this, then bring it in, or do the last 2, hold this. You could even do first and third and hold the middle if you wanted. I always do kind of the first 2 and hold this. Can you tell you're going to get x squared minus x, that's round 1, plus x minus 1, that's round 2. Hold your x minus 3. There's no scheme to go all the way through all 3 at once. Now your x's here are going to cancel, leaving you x squared minus 1 and x minus 3. Now I'm going to FOIL this. X squared times x, that's my x to the third. Minus 3x squared, there's round 1. Are we going too fast?
No, you're doing good.
You're all right.
All right, then round 2 would be minus x and add 3. Once again, just to prove it isn't hocus pocus, I like to literally pick one of these numbers and plug it in down here and show you get 0. So I'll just use -1 with x equal -1. This means I get -1 to the third minus 3, -1 squared minus a -1 and add 3. -1 to a third, that's -1. That'll be a 1, but with the negative, there's -3. -1, that's a +1, and here's +3. So can you see, I mean, you can combine all at once, but can you, -1 add 1, 0, -3 add 3, I get 0. I could do the same thing with these other two numbers plugged into here. I'll get 0. Questions about that?
No, sir.
Okay. 3, 4 is about where exactly did the -1, 1, and 3 come from? Now, I know they give them to you here, but in 3, 4, they're going to give you this polynomial down here and say, find the zeros. And there's theorems for that, and that's the subject of 3, 4. But before we jump on to that, did you want to see any more long division? Something like 23 is a real project.
We can do that. That's fine.
You want to see that one? I should have left 35
that'll be
off. I don't like to mess with fractions. I should have left 35 off. We won't ask you anything like an x minus a half. We're going to stick with whole numbers. It's tough enough with whole numbers, much less fractions. All right, we said 23. All right, this is a real project. You're taking x to the 6, adding x to the 4th, x squared, and adding 1, and dividing by an x squared add 1. So what I do is I take x squared and add 1. It's not a square root symbol. They usually use a little hook for a square root symbol, but they're using a divide symbol. And what I do is I fill in the missing pieces. So I got an x to the 6, a 0x to the 5th, an x to the 4th, a 0x cubed, an x squared, a 0x, and a 1. Are we ready to start the game?
Yes.
Okay. You see how to start the game. X squared times what is an x to the 6? Can you tell that be an x to the 4th? Everybody see where I'm getting x to the 4th there?
Yes.
Yes. Okay. If anybody else isn't, I'd be happy to stop and explain it. If anybody else, see, can you see when I multiply it back, x to the 6 plus x to the 4th. Subtract. And this is a strange one. The lead piece always cancels, but basically you're getting all the pieces canceling here. You're getting all the pieces dying here. X fourth minus x fourth, that's also 0. I really don't have to write down these lead zeros or even this 0 on this one. I really only have to write down the x squared plus 0x, add 1. We do have, since these are equal, you still play. You tell you got x squared times 1 would be x squared, so there needs to be a plus 1. You don't really have to line up the pieces up here. I like to. It doesn't really matter. So when I multiply, I get an x squared and a plus 1. I subtract, and doggo, this one's an even one. There's no remainder. That cancels, there's 0 there, and 1 minus 1 cancels. So my answer really here is just the quotient, x to the fourth, add 1. You add, if you add your remainder divided by your remainder is 0, so you only need your quotient. You understand that that quotient times that divisor equals your dividend. I could show you that, but I don't know if you're seeing enough gibberish. Anybody want to see that check, or do we all believe?
I believe it, but I have a question.
Sure.
Does this normally happen with problems like that?
No.
Okay.
They cooked this one for this to happen.
Okay.
Okay, are we ready? We're 30 minutes in. Are we ready for 3-4?
Yeah, that's fine.
Okay. 3-4. You want to find the zeros. A polynomial. From scratch. Okay, you need the magic theorem. It's called the rational zeros theorem. It reads like gibberish. Okay, they're basically writing out a random polynomial in very general form. And then what they're doing is forming a list of all possible zeros. And they're a ratio. The p on top is the factor of the end number, and the q on bottom is a factor of the leading number, and this will be possible zeros. I realize it's all gibberish till you see an example. Let me do one off the homework. Did anybody get as far as 3-4 in the video? I think I did number 5.
I haven't made it there yet.
You haven't got there yet?
No, sir.
Okay. Do you want the instant replay of, well, it isn't an instant replay for you since you haven't seen it in the first time. But I did 5 in the video. Do you want to see it done here and then you can watch it again, or do you want to see a different one?
I mean, I don't care. I can just watch 5 again.
Okay. So page 319, number 5. The p of x minus 4x squared add 3. Notice the instructions. They're trying to separate this out in baby steps. List all possible rational zeros. List possible rational zeros. What they do is they write it P over Q. I'm going to write it out in words, trying to translate their gibberish. At the top, you need factors of your end number. On the bottom, the end number is this one. You divide by factors of your lead number. That's this one. No number means it's 1. And you don't know what the signs are. So in other words, you need factors on this one of 3 divided by factors of 1. So what you do is you list all the things that can multiply to 3 with all possible signs, meaning plus minus 1 plus minus 3. There's only two things. 3 is prime. Only two numbers multiply to 3, 1 and 3. And you list all the possible signs. Well, 1 is simple enough as well. The only factors of 1 are 1. Again, it could be positive or negative. Now, what you do here is you individually divide every number on top by the number on bottom. This one's going to be pretty simple. Further down, you can get quite long lists. We can show you an example of something, but this is going to be written up. Plus, you can write 1 plus or minus, then 1 divided by 1, and then 1 plus minus 3 divided by 1, which boils down to plus minus 1 and plus minus 3. Zeros of this polynomials will come from this list. Zeros of x cubed minus 4x squared add 3 will come from this list. All right, they tell you in the directions not to find which ones are actual zeros. Actual zeros mean you can plug these in and you actually get 0. But you got to have, in effect, you got to have your candidates. All right, questions about, that's all they want in this little section, little baby problem, forming this list. Do you want to see another one of these? All of the problems of this section are going to start with this procedure. You want to see another one? A little longer?
One, I mean, yeah, I guess one that's longer.
Well, which one you want to try here? Say number 7?
Yeah, we can do that one.
I'm going to need factors of 8 over factors of 2. Page 319. Number 7. R of x. 2x to the 5th. 3x cubed. Plus 4x squared minus 8. List possible zeros. All right, they call this list P over Q, just using their same notation. I'll write it out. I need factors of 8 over factors of 2. 8 being the end number on this one, 2 being the lead number. And you just work your way up from 1 up to the number. Can you tell you need plus minus 1, 2, 3 doesn't, you get a 4. When you get halfway there, you can jump right to the end. Any questions about listing factors of 8?
No, sir.
Okay. Factors of 2 are pretty simple. That's 1 and 2 itself. 2 is the only even prime. Now what happens is we're going to boil this list down. So we take 1 over 1. I'll write it out. 1 over 1. And then 1 over 2. 1 over 1. And then 1/2. 1/2 or negative 1/2 is a possible 0. What's going to happen is we're going to take each number on top individually. I'm going to write it out real slow so you can see it, and we're going to get repeats. And then you can cross off the repeats. All right, so now I go to 2 and I get plus minus 2 over 1. And then plus minus 2 over 2. Can you tell that's a repeat? You're just getting 1 again. Are we losing anybody?
No.
All right, 2 more to go. 4 over 1 and 4 over 2. So plus minus 4 over 1, that isn't here, so that's legal. And then plus minus 4 over 2. Well, that's just 2, and we've already got 2. So that's a repeat. And then the last two are plus minus 8 over 1 and plus minus 8 over 2. Well, 8 over 2 is just 4, so that's a repeat. So if you want to collect this, 1 over 1 is 1, plus minus a half, plus minus 2, plus minus 4, plus minus 8. That is the list of all possible zeros. The zeros of this original will come from this list. Have we lost anybody?
Nope.
Nope.
All right, okay. Are we ready to go on and take the next step? Just before I do, I just want to remind you, the next step is that they're going to have you find which ones are actually zeros. In other words, you plug in and get 0. And remember, if I can, if a number, again, just for example, let's say x equals 4 is a 0. I don't know that it is, I'm just making this up. You understand? That means there's a factor of x minus 4. Everybody get the correlation?
Yes.
Okay, if 2 is a 0, there's a factor of x minus 2. If negative 2 is a 0, the factor is x plus 2. Okay, but again, it didn't have me go on and do this. I'm just trying to remind you that's what we're actually going to do. But the next step is to really nail down which ones are zeros, actual zeros. So that's what I'm going to jump to say problem 15. And they're telling you that all of the zeros are integers. They want you to find, and they mean actual zeros, and then write your polynomial in factored form. All right, do you want to see something like 15?
Yeah.
Okay. Yeah, 3 and 4 here are, you're kind of on the peak of difficulty of the whole class. At least what past classes have told me. X cubed, 2x squared, minus 13x, and add 10. They are saying, find the zeros. They mean actual zeros. So you have to start from the P over Q list. You got to have some candidates to start from. So even though they didn't tell me to make up the P over Q list, that's where I get my candidates, my numbers, my numbers to start from. So my P over Q list would be factors of 10 over factors of 1. 1 being right there. Uh, 10, you'd have 1, 2 would work, 3, 4, no, 5. And then I'm halfway there, so I jump to 10. Factors of 1, still plus minus 1. All right, so can you tell when this happens with 1 on bottom, it just is the top numbers? This means plus minus 1, 2, 5, and 10. That means there's 2, 4, 6, there's 8 possible zeros. All right, find actual zeros. Method 1, long, slow way. You want to guess what the long, slow way is? Plug them in and see if you get 0. Book actually shows you this. Literally, x equals 1. You'd get 1 cubed plus 2 times 1 squared minus 13 times 1, add 10. So you're getting 1, add 2, minus 13, add 10. 3 minus 13 is negative 10 plus, doggone, I think it worked. Hit 1 on the first try. It's almost like fishing. Everybody, this literally is the only way to really do it.
So there's not a shorter version of this?
Well, that's, would you like to see the shorter way?
Yes, please.
Oh my goodness, so polite. Okay, you can get the calculator to do all of this for you. And I covered this in the video today. Would you like to see how to get the calculator to do this for you?
I would appreciate it.
Oh my goodness, okay. Now you understand x equals 1, this means I have a factor of x minus 1. Everybody understand this?
Yes.
Okay. All right, because there are, how many more to go? There's 7 more to go, right? All right, it's called using table function. This is the short way. Use the table function on the TI 84. Okay, I have mine. Yes. What you do is go to y equals like you're going to graph it, but we're not going to graph it. You enter your formula on the y equals. So I'm going to enter x raised to the 3rd, add 2x squared, subtract 13x, and add 10. The calculator now knows this formula is y1. Any questions about that?
No.
Okay. What you want to do is make a stop at table set. See that table set right there? Go to second that. And to start this, you want to make sure your auto is set. Make sure you're on auto for right now. And now you go to table. Second graph is table. All right, now you understand what the calculator is doing here. It is taking whole number values of x and plugging them in that y1 formula. And that y1 formula, that's the formula for this problem that we entered in y1. Okay, so back to graph. So if I enter 12 in that formula, I get out 1870. Anybody want to see it done by hand to prove that, or do we all believe?
I believe.
Now, what are we looking for? We're looking for x numbers that make this what? There's the word right there. X numbers that make it 0. Supposedly x equals 1 is one of them. So let's go up the list and find x equals 1 and see if we get 0. Well, I hit a 0 at 2, and at x equals 1, I get a 0. So I also have a 0 at x equals 2. X equals 2. A 0. Its factor is x minus 2. And we've already found, I did x equals 1 by hand, and sure enough, x equals 1 is a 0. All right. Are we losing anybody?
No.
Is that a lot quicker?
Yes.
All right, now notice power 3. For right now, that means how many zeros should there be?
3.
3. Let's see if there's another one. Further up. Ah, we hit one at -5. If -5 is a 0, x equals -5 is a 0. Its factor is x plus 5. The final answer, well, half the answer is to find these zeros. So I've got zeros, x equal 1, 2, and -5. And then they want you to write in factored form. That's why I wrote these factors underneath these. The factored form, I simply multiply the factors. So it's equal to x minus 1, x minus 2, and x plus 5. Have we lost anybody?
Why is it x plus 5 if you've got a -5?
Because you have to be able to put in -5 and get 0. So in the factored form, if I have -5 here, -5 plus 5 equals 0.
Okay. Okay, that makes sense now.
Okay, and on this side, you have your original polynomial. Let me write it out. On the left side, you've got your root. So what we're saying is this original polynomial, so we've got x cubed plus 2x squared minus 13x, add 10, has these three factors, x minus 1, x minus 2, and x plus 5. We started with that original, and we're saying that it's got these factors. Now you can see the x equals 1, and we showed you x equals 1. Try the -5. You can see it over here. -5 add 5 gives me 0 this side. On this side, x equal -5. I'd have -5 cubed, 2 -5 squared minus 13 times the -5 and add 10. If I don't get 0, I'll quit on the spot. The calculator showed me to, but I'll just do it manually and see if you believe that. -5 raised to the third, add 2 times -5 squared. Okay, and then minus 13 times the -5 and add 10. Drum roll, like a little drama. 0, bingo. Does that give anybody any confidence in any of this, or does it only make perfect sense to me?
I understand it.
Okay. Yeah, the other way you could check it is to FOIL all this back, and you have to come back to this. And if you don't, you're screwing up. Would you like to see that done, or do we all believe?
I believe.
We believe, okay. Well, that's kind of the heart and guts of 3-4, but it all starts with this list of possible zeros. I don't know if you've got the patience, we're at 55 minutes, but it doesn't always come out whole numbers. You sometimes get fractions, and that's when you want to go, if you look at this table set, you want to go to this ask mode. If you got fractions you have to check out, you can stick the calculator in this ASK mode and give it a fraction, and it'll plug it into your polynomial, tell if it's a 0 or not. Do you want to see an example of that, or have we showed you enough tonight?
I'm good.
He's good. Does anybody else want to see anything like that? I cover that in the video at 12 today.
Then that's fine. I can just watch the video.
Okay. All right. Yeah, it's near 10 o'clock. It's probably pretty late on people. Anybody want to see any more? We're going to have quiz 7 tomorrow. It'll be available tomorrow. 5 problems from 3.3 and 5 from 3.4. Same format. True or false. There'll be a Google form to answer on. It's due Sunday. Still got a couple weeks till the next test.
I actually have a question.
Good thing.
How do we see our semester average? Is it on D2L under grades? I don't think
No.
you have anything listed under there.
I have mailed it. I've mailed out grade reports. So after test
Okay.
2, I mailed you out a grade report. That's your
Okay.
last grade report. Would you like, do you still have that, or do you want to see it again?
No, I probably just forgot to check it. That's my bad.
Okay, no problem. It's on your email.
Okay, thank you.
And if for some reason you can't find it, shoot me a note and I'll send it again. It's very quick and easy to send you one.
Okay, thank you.
Yep. I'll try to send the next grade report after the next test, but that'll be in a couple weeks. I'm a little behind on checking quiz. I think haven't checked quiz 6, and there's going to be quiz 7 here. I'm a little behind on checking things. Anybody else want to see anything more, or are we ready to end the meeting?
I'm good.
I'm okay.
Okay. All right. If nobody has any questions, I appreciate y'all coming out this late on a Thursday night, and we'll end the meeting.
Thank you.
Thank you.